everyone, greetings. It is my great pleasure to connect with you all virtually and share some of my tiny learnings on such a great platform. Firstly, we are so happy for GDG Ludhiana as it celebrates its first ever Day Fest. Our heartiest congratulations on this new milestone. We hope you have more laurels ahead. I am Praseeda, a Google DSC lead from GVP College of Engineering for Women and an active core member of GDG YZ. I call myself as an aspiring data enthusiast, but as I explore the depths of it, I do realize that it is not as easy as you say it though. Now, let me share a story. Adya is excited about receiving her guest. She asked her mom, who is coming to the home and how he is related to us. Mom replied, he is just an uncle to you. Adya insisted to go deeper with the relation. Maybe she hasn't realized the complexity associated with it. Upon insistence, mom explained the relationship. The guest is brother of your father's cousin's brother-in-law's wife's nephew's wife's brother. Okay, before you force me to stop it, as Adya too did, she was not just happy with a complex relationship that can be even conceived to open the knots. What do you think of the problem? Yes, the storage. The fact that you need to store individual persons' entities with too many relationships attached to them is perplexing, right? Okay, this is just for a family. What about storing the entire world relationship like this? Going deeper into the problem, let me take a different scenario. Working as an intern at an oncology-driven platform, an AI-based product company, I was able to closely observe how crucial it is the database design. The use case goes like this. The ongoing problem or the ongoing battle is cancer is not an isolated disease, but rather a term of broad class over 10,000 diseases that can cause cells to mutate and multiply without control. These mutations can happen anywhere in the body, resulting in different ailments in each patient. A huge array of drugs already exist to treat the various forms of cancer. However, the real problem with the current treatment is inability of medical professionals to access information that they need to effectively match with the best drugs to individual patients. On top of it, patient-specific factors such as age, gender, cancer type, disease progression, and specific gene mutations can all play a significant role in determining how effective one drug is compared to similar other alternatives. While there is an ever-growing body of global research as to how these factors can affect the way an individual responds to certain drugs, there is currently no centralized database containing all this key information apt. A lot of data remains siloed into research facilities inaccessible to individual doctors tasked with making critical decisions about patient treatment. Of the databases that do currently exist, only very few are intelligent enough to allow tailored searches based on critical patient-specific factors. For example, ovarian cancer is one of the most aggressive forms of cancer. Just 5% of those who are diagnosed surviving for just 12 months from the point of diagnosis. As such, getting right treatment as quickly as possible is crucial. A lot of trial and error method is used to determine and the lack of information and the informed decisions by the system. As a result, time is wasted trying to find the most effective way or treatment that can often mean the difference between life and death. So, when you want to solve such crucial problems, and especially when you want to automate things such as disease detection or disease prevention through AI and automation, there should be an effective database that will be able to process things faster. Of course, my dear friends, by this time, you must be realizing the fact that this affair is not just mere storing of data that could be possible in form of rows and columns. And with all the database subject that we have studied, all the functional dependencies wouldn't be scalable to imagine. We need something big, we need something more scalable. And that is where the concept of graph databases comes to our rescue. Graph databases excel in the tasks related to search and recommendation because they not only store information about things, but also the relationship between those things. The capability allows users to ask questions that were previously possible through the traditional database technologies. The data relationship stored in the graph database can express the nature of each connection and capture of qualitative and quantitative facts about the relationship. Once loaded into the graph database, an entirely new set of relationship-based questions can be asked, opening up for new possibilities. When applied to cancer treatment, it means doctors can ask questions like the following to help tailor treatments to individual patients. Like, find all cancer treatment drugs available since 2012, which has proved the most effective in treating stage 2 of ovarian cancer in women under the age of 30. Oh my god, that is too much of data right in one database. The result is to assist medical professionals in recommending better treatments using data relationships to increase precision and accuracy. My dear friends, I am so pleased to introduce to you the best platform I have ever seen for graph databases, that is Neo4j. Unlike other databases, Neo4j graph database doesn't need to complete the relationships between the data query time, but the connections are already established right in the database. Because of this, queries of deeply connected data are in orders of magnitudes faster. We got introduced to the limitations of the tools we work with, and Neo4j blows off all these limitations wide open, enabling queries never before imagined to high speeds possible. I got introduced to Neo4j through its certified professional examination. I'm happy to share this tailored course, which is meant for all the data aspirants out there, which is offered by Neo4j. I'm sure you must be loving it. Now I'm a Neo4j certified professional. That's it for the day. I hope you had pleasure listening to the session. I hope this experience has not just been delicious, but also data-licious. You can reach me out via LinkedIn and mail. Thank you so much.